Hi, welcome back. Hearty welcome to you. We are solving examples as part of matrices. Without expanding, we have to prove that determinant on the left side, the matrix determinant is equal to 2 times the determinant of this particular matrix. Now, to start with, I see that on the left side I have all sums like b plus c, q plus r, y plus z, and I see on the right side that a, b, c, p, q, r, x, y, z. That means first I have to find out a way to get from left hand side 2 out. If you are able to get 2 out, then I should be able to proceed. Okay. To get 2 out, let us see here what operation I have to do. If I do on row wise, if I add C1 equal to C1 plus C2 plus C3, it's not giving me any result. But if I add R1 is assigned R1 plus R2 plus R3, I see that I may get 2 out. So let me immediately go there and try to apply that. So R1 is assigned R1 plus R2 plus R3. That means B plus C becomes now B plus C plus C plus A plus A plus B. That's nothing but equal to 2 into B plus C plus C plus A plus A plus B. That's nothing but equal to 2 into A plus B plus C. So you can see that I can get 2 out. Once I get the 2 out, then I think I should have some more thoughts on how to proceed. So let me do that. If I do that, I will have 2 into A plus B plus C. Then I will have 2 into P plus Q plus R. And I will have 2 into X plus Y plus Z. And the remaining will stay as it is. C plus A, R plus P, Z plus X, A plus B, P plus Q, X plus Y. Okay. Now I can take 2 common out, right? So let me go ahead and do that. I will take 2 common out. If I take 2 common out, I will have A plus B plus C, CA, C plus A plus B. I'll have another, I'll just erase this, I need little bit more length. Then I'll have A plus B plus C. Oops. That's not A plus B plus C. It's actually P plus Q plus R. P plus Q plus R, and I have R plus P, P plus Q. Then you have X plus Y plus Z and X plus Z and X plus Y. Now look at this carefully. If you look at this carefully, what we want is in the first row APX, second row BQY, third row CRZ. Let us take the first column. In first row I should have A, second row B, third row C. Here I should have B. To get B here, can I subtract from R1, R2, R2 so that A plus B plus C minus of C plus A equal to B. Similarly, if I do R1 minus R3, I will be getting B comma C here respectively. That is what I want? Yes. So what I will do now, I will apply right here R1. I'll say R2 is assigned R1 minus R2, comma R3 is assigned R1 minus R3. Now let us see what it looks like. Now the first row will be as it is. So I'll have A plus B plus C. Then I'll have P plus Q plus R, P plus Q plus R, and I'll have X plus Y plus Z or Z. But when I do R1 minus R2, I will have B here. When I do R1 minus R2, I will have Q here. When I do R1 minus R2 on the third column, I will have y. That is what I want. I want BQY. So we are going in the right direction. Okay. Now let us apply the same thing for the third row also. R3 is assigned R1 minus R3. So I'll have C here, then I'll have R, then I will have Z. Now everything seems to be fine other than the first one should be A, but I have A plus B plus C. First row, first column I should have A, but I have A plus B plus C. But you can see B and C are there already with you, so you can directly subtract them. Now next step will be, I will say R1 is assigned R1 minus of R2 plus R3. Can you see that? If I do that, what happens? A plus B plus C minus of minus B minus C. B and C cancels out. You will have A. So that will give me A plus B plus C minus B minus C. That is A. Similarly P and X, B, Q, Y, C, R, Z. So that is what we want. How we have done that? We see that on the left hand side we have all additions. On the right hand side we have just a simple A, P, X, B, Q, Y without any arithmetic operation, any operation on them. So what we know is, if somehow I can manipulate the left hand side and get 2 out, then I should be able to proceed further. So what I have done for that, I have applied R1 is assigned R1 plus R2 plus R3. When I do that, I get 2 out. Not only that, I get in the first row A plus B plus C, P plus Q plus R and X plus Y plus Z. Now when I compare them with the second row, I see that what I want in R2, R3 is nothing but R1 minus R2 and R1 minus R3. Now everything is fine with second row and third row, but what about the first row? First row I see that whatever I have, whatever I need is nothing but R1 minus of R2 plus R3. So what I have done, I have A plus B plus C, but I want A, so I should get rid of B and C. So I said minus of B plus C, so that B and C are gone. I will left with A and P and X. So that's how we have solved it. So we'll see some more examples in the next video. Thanks for visiting. Bye for now.